Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very nice question on gravitational field from May June 2022, paper 4, variant 2. In this question, we will discuss some very important points about this topic. We will talk about how we can define gravitational potential at a point. We will also discuss how we can derive formula for gravitational potential energy using concept of gravitational potential. Then we will talk about how to calculate change in gravitational potential energy and also change in kinetic energy. Then we will discuss what is the relationship between work done by gravitational force and change in gravitational potential energy. And some other points we will also discuss in today's lesson. So in today's lesson, we are going to discuss very important points about gravitational field. And understanding of this question will help you to understand this topic. Let's study together. Let's improve together. For question number 1, part A1, we need to define gravitational potential at a point. And this question is very common in past papers. Why this question is so common in past papers? Because this concept is very important to understand gravity and gravitational field. That's the reason this question is most frequently asked question in past papers. But let me tell you, in physics, gravitational potential or electrical potential is not defined. When we define gravitational potential or electrical potential, actually we are talking about gravitational potential difference because we use a reference point. So that's the reason gravitational potential is not defined, and also electrical potential is not defined in physics. When we define them, we take a reference point. So we talk about gravitational potential difference, or we can say we talk about electrical potential difference. Now let me explain to you how we can use concept of gravitational potential difference to define potential at a point. So we will take one point as a reference point, and that point will be infinity. First of all, imagine that we have a mass. This is capital M. It has its own gravitational field around itself. So this is the gravitational field. You need to understand gravitational force is always attractive force. So these arrows should be pointing towards this mass. So this is the gravitational field around this mass. Now imagine that we need to find out potential at any single point. Let's say we want to find out potential at this point. Let's say I want you to find potential at point P. If you need to find the potential at point P, you need to go to infinity. Imagine that at infinity. So this is infinity. At infinity, we define potential is equal to 0. Now you need to take one unit mass from this point, means from infinity, and at infinity, kinetic energy of this unit mass is equal to 0. Now you have to move this one and you need to bring this one to this point. Mean you take this unit mass from infinity and you have to bring this one to this point. And when you bring this one to point P, its kinetic energy also has to be 0. It simply means that you have to move this mass very slowly. In order to move this mass very slowly, you have to do work against gravity. So it simply means that if we look at this point, you have to apply force this way. So we can say this is external force, and this force has to be almost equal to very little difference between two forces, means the force of gravity and external force. So slowly you move this one from infinity to point P. So the amount of work done by you, if we divide that one by unit mass, that is gravitational potential at this point. Actually, that is gravitational potential difference because our reference point is infinity. But this is how you can define gravitational potential at a point. So simply in this case, you will say gravitational potential at point P is equal to the work done to bring unit mass from infinity to point P divided by mass means the unit mass. And in this case, you need to understand work done by external force is negative. So that's the reason potential anywhere means after infinity is always negative. So the formula for gravitational potential at any point we have, that is G capital M divided by R, means R is the distance from the center of this mass to point P. So this is how we define gravitational potential. So you need to understand how we define. So let me show you the answer, how you can write down the answer. This is how you can write down the answer. This question has 2 marks. If you have written work done per unit mass, you will get 1 mark. And if you have mentioned to bring unit mass from infinity to that point, you will get the second mark. So you will get 1 B mark here and second B mark here. So this is how these 2 marks will be awarded. I hope your concept of gravitational potential is now clear. How we define gravitational potential at a point. And also you need to understand potential is a scalar quantity. So this is a scalar quantity. For the second part, we need to start from the equation of gravitational potential due to a point mass, and we need to show that gravitational potential energy EP of a point mass small m at a distance small r from another point mass m is given by this equation, and G is the gravitational constant. So first of all, imagine that we have one point mass, and mass of this point mass is capital M, and it has its own gravitational field around it. So simply we can draw this one is the gravitational field. So this is gravitational field around this point mass. Now question is asking us, first of all, we consider potential at this point. Let's say this is point A. So the potential at this point due to this capital M, potential will be equal to minus capital G capital M, and R is the distance from this point mass to this point. So R is the distance. So we can also write down, in this case, R is the distance from the point mass. So this is R. R is the distance. Now we bring another mass, small m, and we place at this point. Now question is asking us to calculate the gravitational potential energy of small m. So the gravitational potential energy, first of all, we need to understand this is equal to mass in the gravitational field times the potential at that point due to other mass, means the heavier mass. So this is the product of potential times the mass. The mass we bring in the gravitational field of another mass. So now simply we need to replace this potential with this one. So we can write down this is minus capital G capital M divided by R multiplied by small m. So that's all what you need to do for this question. Then if you write down these 2 steps, you will get 1 mark, and that is B mark. So this is how this B mark will be awarded. For part B1, we need to calculate the magnitude of the change in gravitational potential energy of the comet as it moves from position X to position Y. Means when comet moves from this point to this point, what is change in gravitational potential energy? So first of all, we can label the mass of the comet small m, and the mass of the star we can label this one is equal to capital M. And we can also label the distance of this comet from the center of this star. Let's say this distance is equal to Rx. We can say this distance is Rx, and the distance of the comet from the center of the star at this point, let's say this distance is Ry. So we can label this is Ry. And now we can use our understanding of gravitational potential and gravitational potential energy to calculate the change in gravitational potential energy. Before we answer this question, one thing you need to understand is that as this comet is getting closer to this one, kinetic energy of the comet will increase, but gravitational potential energy of this comet will decrease. So when we will calculate in this case the change in gravitational potential energy, our answer has to be negative. So let's try to answer this question now. First of all, we need to understand, we need to calculate gravitational potential energy, change in gravitational potential energy. So we will take final gravitational potential energy at point Y minus gravitational potential energy at point X. Now we can write down this potential energy in terms of potential. So for potential energy at point Y, we can write down this is potential at point Y minus we have gravitational potential at point X, and we have to multiply this one with mass of comet. Now we can write down potential at point Y, that will be equal to negative gm, means the mass of the star, divided by distance from the center of the star, ry, minus, and we have also minus sign here because potential is negative, divided by rx. Multiply this by mass of comet. Now we can further simplify this. We can write down this is negative gm over ry, and this one we have plus g capital M divided by r sub x, and this is multiplied by m. Now in this case you can see we have gm, we can take this common, so we have g capital M small m. It is already out of the bracket, so we can write down this one simply in terms of rx and ry because we have taken gm common. So we can write down this is 1 over r sub x minus we have 1 over r sub y. We need to plug in values. That's all what we need to do now. In this case, value of G we have that is equal to 6.67 times 10 to negative 11, and this one has to be multiplied with mass of the star, and mass of the star is given here. So this is mass of the star, that is equal to 1.99 times 10 to 30 kgs, and small m is mass of comet, and this is mass of comet. Mass of comet is 2.20 times 10 to 14, and we have to multiply this one with 1 over rx. Rx is the distance of the comet when it is at point x. At point x the distance is given, that is equal to 8.44 times 10 to 11 minus when the comet is at point y, means the distance between center of the star and center of comet when comet is at point y. At point y distance is also given to us, so here this is the distance. So we have this is 6.38 times 10 to 10. Now you just need to use a calculator. Put all the numbers in your calculators, but be careful with the signs, and you will get your final answer. Final answer in this case will be equal to 4.23 times 10 to 23 joules. But your answer will be negative, and negative simply tells us that gravitational potential energy of the comet is decreasing when it is moving from point X to point Y. So that's all what we need to do for this question. And for this question, if you have written this step, you will get 1 mark, that is C mark, and the second mark is answer mark if you have got the right answer. This is how marks will be awarded. Always approach gravitational potential energy using concept of potential. Very important tool to answer this type of problems. For the second part, we need to state with a reason whether the change in gravitational potential energy in B1 is an increase or a decrease. We have already discussed in part 1 that energy decreases. So we can simply state gravitational potential energy decreases. Now we need to explain a reason. In order to explain a reason, we need to understand change in gravitational potential energy and how this is linked with work done by gravitational force. Change in gravitational potential energy is equal to negative of work done by gravity, or simply I can say by any attractive force. So that is also true for electrical force when electrical force is attractive. So simply we can say for attractive force. If the work done by attractive force is positive, it means the change in gravitational potential energy will be negative, and vice versa is also true. So simply we can say if work done is positive, so we can write down 2 points here. Change in gravitational potential energy is positive if work done is negative. If work done is negative, simply we can say delta U will be positive, and delta U will be negative if work done is positive. that in this case work done is positive, means gravitational force is doing positive work, so the gravitational potential energy is negative. So simply we can say, as in this case work is done by gravitational force, so the change in gravitational potential energy is negative, or simply you can say gravitational force is attractive, so gravitational potential energy decreases. You can write down any one point and you will get 1 mark. This question has only 1 mark. Let me show you how you can write down your answer. This is how you can write down your answer. You can say gravitational force in this case is doing positive work, so GPE decreases. And this question has only 1 mark. If you write down this point, you will get 1 mark. Now simply you can say, as gravitational force is an attractive force, so GPE decreases. You will also get 1 mark. Means still you will get 1 mark. If you write down the first one or the second reasoning, you will get 1 mark. Very important point you need to understand. If work done by attractive force is positive, change in GPE or change in potential energy will be negative. If work done by attractive force is negative, change in potential energy will be positive. You can also imagine that this one, let's say I have this small box. If I raise this one, in this case work done by gravity is negative, so the potential energy increases. But if I lower this one, means if I drop this one, work done by gravitational force will be in this case positive, so its gravitational potential energy will decrease. Very simple concept, but most of the time many students, they're not clear about this one. Concept is very simple. If the work done by gravity, if I raise this one, work done by gravity is negative, so the gravitational potential energy of this box will increase. But if I drop this one, in this case work done by gravitational force is positive and its gravitational potential energy will decrease. And this is what is happening in case of comet and star. So gravity is pulling this comet, so work done by gravity is positive and gravitational potential energy of this comet is decreasing. For our third part, we need to use our answer in B1 to determine the speed in kilometers per second of the comet at point Y. So this is hint, means we need to use our answer from B1. In B1 we have calculated change in gravitational potential energy, and in this system there is only one force, that is gravity. So it simply means that in this case mechanical energy of this system is conserved. So we can simply say loss in GPE is equal to gain in KE, and loss in GPE means the change in gravitational potential energy we have already calculated, that was equal to 4.23 times 10 to 23. Now we need to calculate change in kinetic energy, and then we can find out the speed of this comet at point Y, means at this point Y. We can find out speed of comet. And let's say this speed at point X is Vx, and the speed at point Y, let's say this is Vy. And we need to calculate in this case Vy. So we can write down the formula for change in kinetic energy. In kinetic energy, mass is common, so we can take out, so we can write down speed of the comet at point Y minus speed of the comet at point X. Now we can plug in values for mass. Mass of the comet is 2.20 times 10 to 14 times we need to calculate Vy. So simply we can write down Vy square minus Vx. Vx is given to us here, so this is value of Vx, but we have to use meters in this case first of all, so we have to multiply this one with 1000 and square of this one, square of this. And now we can solve this one for the value of Vy, value of Vy. If we solve this one for the value of Vy, our final answer in this case has to be equal to 70.8 kilometers per second up to 3 SF. So this is our final answer. Simply you need to understand for this question, mechanical energy is conserved. So the change in gravitational potential energy is equal to change in KE. And simply you need to equate and you can find value of Vy. And your answer has to be in kilometers per second. This question has 3 marks. The first mark you will get if you have written this step, you will get 1 C mark, and the second C mark you will get if you have sub these values, and the third mark is the answer mark. If you have got right answer, you will get 3 marks. So this is how marks will be awarded for this part of the question. For part C, it is given to us a second comet passes point X with the same speed as the comet in B. Traveling in the same direction, this comet is gradually losing mass. The mass of this comet when it passes point X is the same as the mass of the comet in B. Suggest with a reason how the path of the second comet compares with the path shown in figure 1.1. A bit tricky question. Let's try to understand this one step by step. First of all, imagine that we have one mass capital M. You can imagine that this is our planet. You can imagine this is Earth. And there is a satellite or any other object that is orbiting around this heavier mass. So this one you can imagine is satellite or any other object. Now, if we try to calculate the orbital speed of this one, we need to equate centripetal force with gravitational force. Mean in this case, orbital radius, first of all, let's say this is capital R. This is orbital radius, not radius of this heavier mass. So in this case, centripetal force will be provided by the gravitational force between these two objects. So here we will have R squared. Now we can cancel this M with this M, and we can cancel this R with this. So we will get V in this case, V will be equal to G capital M over R. And this V is the orbital speed. So this V is orbital speed. Now from here we can see that orbital speed does not depend on mass of satellite, or it does not depend on mass of object in orbit. If I replace, let's say, this satellite with another satellite, and mass of that satellite, let's say, is equal to M1. So you will see M1 again will be cancelled. So the first thing you need to understand in this case, orbital speed does not depend on mass of orbiting object. It only depends on mass of this heavier object, and it depends on orbital distance, or simply you can say orbital radius. It is depending on these two. It is simply depending on mass of this heavier object, and it is depending on orbital distance, or you can say orbital radius. Let's try to answer this question using concept of energy. Before we use concept of energy, we need to understand this comet is made of many small pieces. Means we need to imagine that it is made of many small pieces. So this is comet. You can imagine that this is made of many small masses, and on the way from X to Y, this comet is losing mass. Now if you look at orbit of any one mass, we will see that change in gravitational potential energy, this is equal to change in kinetic energy. And in this case, change in gravitational potential energy is equal to m times delta phi, and the change in kinetic energy is equal to v square minus u square. So mass is on both sides, so mass will be cancelled. So each piece of comet will follow the same orbit. So this is what you need to understand for this question. And for the sake of answer of this question, simply this is how you can write down your answer. Let me clean this one so you can see what I have written. So simply you can say, as both potential energy and kinetic energy equations, they include m, so the path is unchanged. The main concept is you need to visualize it is made of small pieces, and it is losing some of the pieces, and the orbital speed of any mass is independent of the mass of the piece itself. So that's the reason it will follow the same orbit. I hope this is clear to you. If you have any questions, leave your questions in comments. And we have finished May June 2022 paper 42.